All right, section, what is this? 2.3.2, autonomous differential equations. And in this case, this is any differential equation where we would write u prime is, well, for us, for a first order, the stuff we're going to study here. So u prime is just some f of u. Okay, so there's no t showing up. So you could have our u prime equals some k times u that gives us our exponential function. We had u prime equals say something like k times u minus, and I'll just put a 7, okay, because again that's doesn't change with t. Okay, so the idea is nothing changes with t, and that's all it is. That is an autonomous differential equation. But with such a thing, notice you can then set u prime equal to 0 and solve for u. And when we do that, then for instance, in our first one there, we would have ku is equal to 0, so that implies u equals 0. Well, what that means is if u of t equals 0, it stays there. Okay, is what we know. As the derivative 0, so there's no change, and it won't change with t. So you see, once u is 0, it's stuck there because t cannot do anything to change it. And so similarly, if we had k times u minus 7 equals 0, that would imply that u equals 7. Then if u of t is equal to 7, it's stuck. Okay, so we call these equilibriums. Equilibrium values for the autonomous ordinary differential equation. And again, we're just looking at first order here. Certainly you could do things like this with second order and all that, possibly. And so that's what we're looking at with autonomous systems, and in the next couple of sections. But that's all there is to it, is just kind of trying to, essentially it comes down to an algebra problem, because you're given this, we set it equal to 0, and we solve for u, or whatever the variable happens to be, to determine these values of equilibrium. And of course, we could have more than one equilibrium value, right? That would be simple enough if I had, something like u prime of t is equal to u squared minus 1. then when I set that equal to 0, I would get u equals plus or minus 1. And so we still have this first order equation, but it's nonlinear, and so we would have equilibriums here at u equal plus and minus 1. Okay, so certainly we could give you some really hard algebra, but the idea is always the same. We're just trying to find out where our function has equilibriums, given that we've described the function in terms of an autonomous differential equation. All righty. So that is autonomous differential equations.